Hi, Trenton. So here's the question you asked about. I will get you started on it, and if you can't finish based on what I do, then you can, of course, email me back and let me know. So here's the question that you were asked, which I'm sure you're familiar with. You're supposed to find an exponential function that models this data and ultimately answer this. When does the purchasing power drop to 40 cents? So let's look at that. Okay, so if somebody asks you to find an exponential function, they want you to find a function that looks like this: f of t equals y sub 0 b raised to the t. Okay, so y sub 0 is a number, and b is a number, and t is a variable. So when somebody asks you to find an exponential function, they want you to find the number y sub 0, and they want you to find the number b. So that's your task. And they want you to find those two numbers based off of this data right from the question. And let's see, yeah, so t equals 0 corresponds to 1983, and they want you to answer this question ultimately. So you will find this function to model the data to help you predict things. In this case, predicting when the purchasing power drops so low. Okay, so keep that in mind. The first thing you need to do on any question like this is find the constant y sub 0, find the constant b. And if you remember the question, it said use the first and last points. So here's the first point, 1983, when the purchasing power was 1.02, and 1995, when the purchasing power was 0.85. So those are the 2 points we're going to use. Okay, so 1983 is the same thing as t equals 0. And in that year, the purchasing power was $1.02. So let's just see what that means. Okay, so here's what we're aiming for. We're aiming for a function that looks like this. Let's just interpret this statement up here, the fact that in year 0, the purchasing power was 1.02. Let's interpret that in terms of this function. So in particular, in year 0, the purchasing power is $1.02. That's what this is saying in plain English. In year 0, when t equals 0, the purchasing power is 1.02. Because this function is modeling purchase power. So when you input a year number, it's going to output a purchasing power. So this statement is true by definition from the table. So let's just chase through what that means. Well, if f of 0 is 1.02, f of 0 is also y sub 0 b to the 0. Because when you write f of a number, that literally means plug that number in for t. So if I plug that number in for t in this equation here, t becomes 0, therefore f of 0 is y sub 0 b to the 0. And so you can just put these two facts together. 1.02 is f of 0, which is y sub 0 b to the 0, and you learn this, that 1.02 is y sub 0 b to the 0, but anything raised to the 0 power is just 1. So ultimately you've learned that y sub 0 is 1.02. Okay, that's what you've learned. So you used 1 point in the data to tell you what this constant y sub 0 is. And so if your ultimate goal is to find both y sub 0 and b, you are halfway there. So your function now looks like this. You can actually fill in what y sub 0 is. You've learned that y sub 0 is 1.02. So our next task is to find what b is. So we've used 1 point, the 1983 point, to find b. We're now going to use the year 1995, which was the last point, to find b. Okay, so in 1995, which is year 12, the purchasing power was 85 cents. So let's just do the same thing we did on the previous slide. In year 12, the purchasing power is 85 cents. So this equation is true. Oh, but if f of t looks like this, then when you plug in 12 for t, you literally get 1.02 b to the 12. And so once again, we get that the purchasing power in that year just is 1.02 b to the 12. So now if you want to find b, it's slightly more complicated. So So you need to isolate b. So the first thing you do is divide both sides by 1.02. If you divide both sides by 1.02, I get 0.8333, etc. on the left-hand side. And now if you want to isolate b, to cancel out the power of 12, you have to take 12th roots. Just like if you had a b squared, you'd take square roots. If you had a b cubed, you'd take cube roots. So I'm going to take 12th roots of both sides, which you can do on your calculator. And I learned that b is 0.98492, approximately. I rounded off. So notice in both of these lines here, I did some rounding. I cut off the decimal. You need to be careful. You want to keep enough decimal places that your final answer isn't too far off. So keep 5 or 6 decimal places anytime you do that. Okay, so this is my final function. I learned what y sub 0 is, and I filled it in. I've learned what b is, and I filled it in. So notice this function does what it's supposed to do. So for example, if I plug in 2, year 2, that's the year 1985. And let's look back at the data here. In the year 1985, the purchasing power is supposed to be 99 cents. And that's what this function gives me. If I plug in the year 2, I get 99 cents. So this function is a model of that data. And once you have a model, you can now predict anything you feel like. So I'll leave that up to you. So let's see. So your ultimate goal was to answer, when will the purchasing power of a dollar be 40 cents? Well, this function represents purchasing power, where t represents year. So again, I'll leave that to you. If you can't figure it out, let me know. But just use this model to answer the question.